Hi, Earth scientists. Welcome. In this lesson, we are going to be talking about how rocks change and where you can find each type of rock in the rock cycle here in Wisconsin. Rocks are always changing, whether that happens instantaneously or over millions of years. And rocks change in two main ways. We've been talking about, since the week 1 lesson, the rock cycle. We are also going to talk about weathering and erosion and how that affects rocks. Rock cycle, as you may remember, is a process by which our three main types of rocks, sedimentary, metamorphic, and igneous, change in between each other due to this process of weathering and erosion, or the addition of heat and pressure, or through melting and cooling. We learned about this in our week 1 lesson. Weathering and erosion are another way that rocks are altered and moved around on the surface of the earth. This is actually a minor part of the rock cycle, but it's the part that we can directly observe here on the surface of Earth. Weathering and erosion are related, but they are different. Weathering is when those rocks physically break down due to the elements like water, wind, plant roots, humans stepping on them, ice. Erosion, on the other hand, is when that rock bit or the whole rock is moved, transported due to those same elements. Water, wind, maybe it's a landslide, an earthquake. So the difference here is weathering is breaking it down, beating it up, whereas erosion is the movement from point A to point B. Think of it like an old sidewalk. Go ahead and close your eyes and picture the sidewalk outside of your house. What does it look like? Is it brand new? Can you tell that it's aged a little bit? Does it have cracks? Is one part higher than the other? Are there plant roots sticking through it? When a sidewalk gets weathered, it looks like what you see here on the screen. There's lots of cracks. That one solid slab of concrete has now broken up into many tiny little bits, and that happens from water infiltrating and then freezing into ice, expanding and breaking up that concrete. As you can see, there are plant roots coming through this sidewalk. That further breaks it up. Wind comes and breaks it up. People are stepping on it. That helps break it up. This is all weathering. It's still staying in one place. It's just that that one solid piece of sidewalk has broken up into many little bits and is breaking apart, further cracking. If there were to be a big flood, or maybe a tornado, high winds can pick up these little bits of the sidewalk and move them from point A to point B. Or like you see here, sometimes there are powerful flooding events that move an entire road from point A to point B. This is erosion. And that stuff is getting moved. It's erosion. And this is all part of the rock cycle. Weathering is when you break it down at the source. Erosion is when you move it from point A to point B. An essential part of the rock cycle. So let's talk about where in Wisconsin you can find some metamorphic rock examples. Remember, a metamorphic rock is when an original source of rock, like maybe it's sandstone or limestone or granite. Metamorphic rock is when that rock originally is altered due to heat or pressure, and the chemistry actually changes, which changes its appearance. If you've ever been to Devil's Lake State Park, you've seen metamorphic rocks. Devil's Lake State Park was originally sandstone. So, over millions of years, sand was deposited, and the weight of the sand being put on top of that compacted it into what is called sandstone, well, that sandstone was introduced to heat and pressure due to the rocks on the surface and the plates moving around, pushing into each other. That changed the chemistry into quartzite, which looks a little different than that sandstone. It's got this purple hue to it. When you go to Devil's Lake State Park, you'll see lots of this quartzite, like balanced rock. You can find a lot of sedimentary rock examples in Wisconsin. A notable example is St. Peter's sandstone. Sandstone and limestone usually look something like this on the bottom right of your screen. They are layered. As you can see in this diagram, over time, that weathered and eroded sediment, it gets transported somewhere and piled on top of each other. Over time, the weight of that sediment starts to press down and squeeze the layers underneath it, compact it together, cement it together, until it's so tightly packed that it stays together and it becomes a limestone or sandstone sample. When you're driving on the highway from Madison towards Iowa, you'll see lots of cutouts near Mount Horeb and Verona. You'll see lots of cutouts on the side of the road that will look like this. That is a great place to study geology. And that is what the ground underneath most of our feet looks like. Layers and layers of limestone and sandstone. In the Driftless area, just west of Madison, you can see lots of examples of that limestone material that's stacked in layers and full of caves and fossils, like this one. You can see here in this sample, this limestone, you can see the layers. Look at that, first of all. You can see the layers of that limestone, sedimentary rock. Contains a ton of fossil clams and other organisms. So if you're looking, you can find fossils out here near Madison. Some other common fossils might look like this, if you're lucky, an ammonite fossil. These are ancient creatures that were put in that sediment when it was still loose, like sand and mud, put in there when it was soft, got buried and preserved, and solidified into this rock material, kind of like this one here. Half of an ammonite shell and got broken up. A famous rock type that you can find in Wisconsin. In fact, it is our state rock, Wausau red granite. A long time ago, 1.5 billion years ago, there was an area of Wisconsin that was sort of like Yellowstone National Park. It was where magma got pretty close to the surface. It caused some geothermal activity near the surface. Well, anyways, over time, these batholiths, these magma chambers underneath the earth, they cooled down and they solidified. And that left behind a bunch of this beautiful red granite. You've maybe seen it in some of our state parks, specifically up north near Wausau. You may have seen it on a kitchen countertop, as it's a really beautiful rock. There are many different rock types that you can find in Wisconsin. It's a very interesting context geologically. For example, up north, there was something called a continental rift. Basically, that's when the earth is kind of coming apart and that lava, that magma, gets to ooze out in those cracks. Well, that left behind some igneous basalt, which looks like this. And here are some areas in Wisconsin where you can find examples of that rock type. You can also find a lot more of this granite, which looks like this, looks like that beautiful countertop. You can find a lot of different examples of granite and gabbro, which have those large crystals because they cooled slowly and they formed underground in these cooling magma chambers. Feel free to look up some of these county parks to see pictures and examples and maybe visit one. There's a lot of metamorphic slate, schist, quartzite, all of these rock types that were originally something, but because of heat and pressure were then altered. You can find that at these few places. And of course, limestone, shale, sandstone are plentiful in Wisconsin, specifically in the driftless area, which is west and northwest of Madison. This sediment was laid down when Wisconsin was covered by a large sea and compacted into stone. It's full of fossils and caves. Many places near Madison. I could ride my bike to Governor Dodge and Cave of the Mounds, very close to here.